Is that as soon as I do I'll get to say, yeah, I'm security, and people are like, oh, okay, let me give you my password.
All right, can you guys hear me? Yes. All right, how's everyone doing today? Enjoying DerbyCon? We had too much to drink last night.
Yeah.
All right. Okay, so thanks for coming out to my talk. Today I'm going to speak to you about exploiting Soho routers. The primary focus of this talk is going to be discussing research that I performed with my colleagues at Independent Security Evaluators. We're going to be talking about applying application security to Soho routers and learn how the vulnerabilities in these devices lead to a root compromise. All right, so who am I? I'm Jacob Holcomb. People may know me from IRC as Gimpy. I'm a security analyst at IRC, as I stated. Why is the information in this presentation relevant to you? Well, every one of you probably has a Soho router at your house. Some of you probably take custom firmware and maybe make your own router with certain hardware you have, but chances are the majority of you are using these devices. 100% of the routers that we evaluated were vulnerable to attack. Whether the attack included some form of user interaction or no interaction, we were able to root every device that we looked at. Okay, so about ISC real quick, who are we? We're just a bunch of ethical hackers and computer scientists. We primarily focus on Fortune 500 enterprises and securing them and looking at their applications. And our perspective is primarily white box. When we do independent research, like I'm presenting here, obviously it can be white box, so we approach it with the black box perspective and apply techniques that we use during the white box evaluation, like source code review, to routers, to the projects. All right, so really quick, I would like to acknowledge some of my coworkers from ISC. I'd like to give a shout out to Paul from Paul.com. You mentioned our research several times, one time in a SANS webcast that I have listed here. And then Greg Hefner. He works at Tactical Network Solutions, has a great blog on embedded device hacking. Okay, so real quick, as I said, we were doing research. We put out 2 papers. The first paper kind of talked about exploiting these routers from a remote perspective. So we assumed that the devices were in a default configuration. They were plugged into the network. The user may have changed some settings, but they didn't enable anything or any services to the WAN. So an attacker had really no footprint to attack. So they had to target the client to then leverage vulnerabilities in the router by using client-side attacks to compromise the router. The second study, the exploiting Soho router services, put perspective aside and just kind of looked at the router as a whole and said, okay, what's running on this device, what's vulnerable, how can we root it? So topics we'll be covering today are what are Soho devices, the players in the market, the technology that these routers use, testing methodology we use to exploit the devices, the actual exploit research and development. I'll be showing, I think, 4 demonstrations, 2 of which are video, and I'll be giving 2 live today. And then we'll briefly talk about some of the mitigations to the vulnerabilities. Okay, so holy hole in the router, Batman. Here is a list of the CVE numbers that we received for vulnerabilities that we found in routers. Not every vulnerability that we found was classified as a CVE. And some of the vulnerabilities that we found were duplicates, and we were only issued 1 CVE. So there's 56 vulnerabilities up here. Really, the list is much greater than this. And some of the attacks range from, like, very simple things, like information disclosures. And you have cross-site scripting, cross-site request forgery, buffer overflows, command injections, backdoors, the list goes on. All right, so what are Soho network devices? Well, basically, it's just an embedded system. It's a small-scale networking equipment or piece of networking equipment that small businesses or consumers, such as home users, will use. Large enterprises will use these devices. In most cases, they'll be supplemental devices. So Let's say that you had enterprise-wide and they had this wireless infrastructure. Let's say it's a Cisco shop, so they're using all the air access points. They have the Cisco wireless LAN controller. They have one area of the building that has very sketchy wireless coverage. Instead of maybe spending $1,000 on an access point, they're going to go grab the $200 access point and plug it in there. So these devices are in these types of networks, and they do allow an attacker to gain access to an enterprise network. All right, so players in the Soho market. This is a non-exhaustive list. There are more, but these are some of the big names and the names that we evaluated.
Someone started playing another video on the same machine this was recording on, so it screwed up the audio here.
Users, small businesses, Quickie Mart, my example, and the large enterprises. All right, so here's a list of products that we have evaluated. I categorize it by the vendor and then the corresponding models. Most vendors, there were 2 models that we evaluated. All right, so why did we choose these routers? Well, as I said, they're popular brands. The vendors are well known. Chances are, if somebody talks about Soho router, you're going to know one or more of the vendors that was listed. All of the models that we looked at have been given awards by like CNET or like Consumer Report, and they're talked up a lot. So they're a popular router that not only do the manufacturers.
Hello, this is Iron Geek again. Unfortunately, the person recording this talk started playing the video from the previous talk, the one on hackerspaces, while it was recording. And unfortunately, that caused the audio to be overlaid. And I'm not sure if it was because it was close to the camera and it picked up the audio there, or if somehow the software automatically puts it on there whenever it's seeing system sounds played. But regardless, people like Skydog and Dave Marcus and so forth projected a lot louder than Jacob did, so it kind of overwhelmed the audio here, and I've put it in silence. Sorry about that, but it's going to be about 6 minutes, I think, before the audio starts up again.
just going to try and jam in a bunch of input into the service and hope that it kind of just spazzes out. All right, so analyzing web applications. In order to, thoroughly assess the application, you have to understand how it functions, how it operates. And in order to do that, you need to know the types of languages that are used server-side and the types of languages the client uses on the client side. You need to know the protocols and APIs used, otherwise, how are you really going to develop an attack? And some great tools to do this is web proxy, fire mode, and a web crawler. I didn't list the specific web crawlers, there's a ton out there. You can even quickly script your own Python. But Burp Suite is great. It's a very handy tool. Not only is it a web proxy, but it allows you to kind of capture requests, replay them, and then also use like an intruder functionality, which is, I believe, what you want to call a web buzzer. It basically takes the request and allows you to change out the inputs, the HTML parameters, and just keep sending them to the application. Firebug is a great tool. It's really just the development tools that any browser has, but I like the interface it provides and the usability. So I provide a few pictures here, just capturing a request in Burp Suite, and then inspecting some HTML elements in Firebug. So analyzing servers. There's not much to do in this phase. It's pretty simple. I mean, you really want to look for authentication. If the server doesn't support authentication, well, that's great. It makes exploitation that much easier. If it does support authentication, you need to know whether or not anonymous access is available. You need to know whether or not the password is certificate-based. Or whether or not there's been misconfigurations. And by misconfigurations, I'm referring to services like Samba that allow you to authenticate and then have access to content you shouldn't. And we'll kind of talk about that more later. All right, so yeah, static code analysis. So if the source code is available, get it. Things to look for are logic flaws, so authentication or authorization. Can you bypass authentication? Possibly. Can you gain access to content without authenticating? Most likely. And then you want to look for like functions not performing bounds checking. It's great. What's that going to lead to? Most likely buffer overflows. Buffer overflows are awesome. And then of course backdoors. All right. I don't know if you guys can read that. You guys read that? All right. So I'll talk about it briefly. I apologize. We need to change the resolution. So here's a piece of vulnerable code from the TreadNet to A12 PRU router. And this vulnerability right here took user input through the web application and it put it into a fixed length buffer. So not only did this cause a buffer overflow, they're also running system on your input. So you have a command injection vulnerability as well. It's great. All right, so fuzzing, dynamic analysis. Really, before you start fuzzing, you have to understand how the application works. I mean, you can do a kind of a sweet trick and just deadly random send input to the application, but maybe, hey, I got a crash, hopefully. But really, you need to understand the application and develop a smart fuzzing template. And what I mean by smart fuzzing template is, let's say the application had 3 commands, commands 1, 2, and 3. Well, you obviously want to put those commands in a template, so when you make requests to the application, they're going to properly be fuzzed. And you need to know the types of protocols that the server uses. So you're not trying to fuzz a TCP server with a UDP protocol. I list some great fuzzers here. One of my favorites right now is Spike. Spike's great, and when you hear me talking about templates, that's what I'm referring to. And I'll show you a template on an upcoming slide. We use the Spike API to create web requests, fuzz a web server. Bed is a Perl script. It's great. You don't really have the ability to customize it, I guess, unless you customize the Perl script, so I take that back, you can. And then the Metasploit framework, and of course Python. Python's great. If anybody wants to just look up a fuzzer in like 5 seconds, you can. Okay, it's exactly right, but it's pretty quick. Alright, so here's a picture of the Spike template. Again, I'm not sure if you're able to see it. So there's a few API calls that you can use in Spike that basically set up a request, and it's s_string was basically just creating non-changing strings, so like a constant string, and then s underscore string underscore variable, and those are going to be the fuzz points. And whatever you specify in that point is going to be changed out of data by spike. So here, I'm just doing a HTTP GET request, setting the host header and the user agent header. And then here is actually a picture of me using that template to flood the web server. So I come up with new programs, generic send, TCP, generic send, BDP, which you'll use based on the transport layer protocol. You specify your target, the IP address, and the port, the template you want to use, and it will start fuzzing. Now, if you had a premature crash, which can cause an overflow, you can resume fuzzing where you left off. So you don't have to start all over. Alright, so analyzing fuzzing results.
There's a monitor for the crashes on the events.
A lot of times the service won't be available anymore, so Spike will just stop, or any buzzer will stop, because you won't be able to get the connection to that port. Alright, so tools. I mean, once you have a crash, or you notice that you may have a crash or some form of bug, you want to load up a debugger and put the service into a debugger. These devices, dependent devices, run links. So if you have a picture of GDB, and this is specifically for MIPS, and this is while I was debugging the ASUS exploit that I'll demonstrate live. As you can see, we have 42s, a bunch of yes registers, and 42 is the hex representation of D. And the system call tracer is another great one. You can attach it to the process, and as you're plugging in or crashing, you can see how it interacts and the calls that it's making. All right, so gaining access continued. Router binaries are really a great piece of information. If you don't have source code, and you can get your hands in the binaries, you can use simple reverse engineering techniques to understand how this application may work, especially if there's no documentation, to then build your smart bugging template and hopefully find some form of bug. Additionally, for reverse engineering, you could reverse engineer the firmware. In most cases, you don't have to. The source code will be available. But one thing I do want to note is most people that I've seen that do embedded device research, in order for them to get shell access on the device for testing and debugging, they will do some form of hardware modification. In all cases where we didn't have console access and we needed to get console access before we could extract these binaries, we came up with the technique that I call a jailbreak technique. So kind of local exploits that we could use on these devices that weren't usable remotely, that then gave us access where we could extract the content we needed, perform simple reverse engineering on it, and then move forward. So some simple tools are strings, hexdump, and grep. Strings is great. There was one service specifically which ran on the ASUS router that I'll be exploiting today, this router here. And the service was ACSD. I had no idea what it was. There was no documentation online. All I knew is that it was coded by Broadcom. Well, using strings allowed me to figure out the commands that the device used, or that the service used, so we could then formulate a proper template, fuzzing template that is, and was the service. And little did we know, we got a crash, and it led to remote code execution. All right, so here's just a picture of running strings, TP-Link firmware. Again, you guys can't see it, but it'll show you information like the bootloader, manufacturer, commands like I talked about, etc. Picture of grep. I wish you guys could see this. This is funny. All right, so has anybody ever grep for backdoor in source code? Well, if you haven't, start doing it. Put it on your list of things to do. While looking at ThreadNet routers again, we were actually looking for command injection vulnerabilities. And as we're going through the source code, we came across this text that says "add backdoor feature," and it was by Tom Home. All right, I'm like, what the hell is this? All right, well, if you look down a few more lines, you actually have functions called backdoor. So what this did is this backdoor allowed you to make a request to a web server with a static string and enable a telnet server on all interfaces, unauthenticated. So you have to
Those are the Broadcom code.
Yeah.
So that it's written to
right here I'm listing just one model specifically, but once I found this, I went to DerbyCon's website and downloaded some additional source code repositories and then looked through the source code, and yeah, it existed. Same backdoor. They changed some things about it, so it wasn't a mistake. It was definitely intentional. And I believe from other research, this similar backdoor was discovered in ASUS devices as well. So, I mean, I don't know how many devices and attacks, but probably a fair amount. So yeah, grep backdoor. All right, so exploit development. I'm not sure if you guys remember all the vulnerabilities that we had on the list, or that I had on the list of CVEs. But specifically today, I'm going to be talking about cross-site request forgery, command injection, directory traversal, and buffer overflows. And we'll go into them. We'll briefly cover what they are, cover how you can mitigate them, and then how we exploit them. All right, so cross-site request forgery. Who knows what CSRF is? Anybody? A few hands? Great. All right, so cross-site request forgery is actually a very handy attack. It's nothing new, it's not groundbreaking, but it's amazing, and a lot of people overlook this, especially developers. What this allows you to do is take web application requests, forge them, trick an unsuspecting user into viewing these requests, so browser then executes the request, sends it to the web server, and will execute actions that the attacker chose. So as an example, let's say I want to add an access to an application, and I do the request structure of the application. I could forge that request, host it on a malicious web server, have compromised another website, posted my code there, and then somehow trick a user, an administrator of this application, into viewing that code. As soon as they view that code, the browser then would render it, execute it, send it to the web server, execute the request, and I would have an admin account on that application. It's as easy as that. Alright, so testing for cross-site request forgery is pretty straightforward. There's two main things you want to look at. Those things are anti-CSRF tokens, so really amounts, and then whether or not the application is doing referrer checking. Anti-CSRF tokens are basically a dynamic value that's added to the web form every time a user logs in or every time they make a request. So this value changes, and it's part of the request that the web server will process. And with this value excluded, the web server won't process the request. So therefore, how is the attacker going to forge the HTTP form or the HTML form? HTTP referrer checking is another method that, when used by itself, is very worthless. It can be bypassed, but it would take a more sophisticated attacker to bypass it and not some script kiddie. These two mitigation techniques, when used in conjunction with one another, are great. All right, so just the countermeasures. Users, every time you're done with an application, log out. If you have an authenticated session and you come across a CSRF exploit, well, you're going to execute a request, and hopefully it's not going to do anything bad, but you have no way of knowing. Developers, we just talked about this, implement both anti-CSRF tokens and referrer checking. Use both of them. If you really want to take it to the extreme, make the users re-authenticate before they perform a state change, like updating user account information. So those three mitigation techniques would be great. All right, so command injection. Who knows what command injection is? All right, a few more hands. Great. So this is a based off the name. It's kind of obvious what it is, but this allows you to basically take application-specific commands and inject them into an application. In this case, we're focusing on a web application. And the web application is going to take that user input, process it, and execute system commands. All right, so testing for command injection, it's really like any other vulnerability. You have to survey the application, you have to understand how it works, and understand where there may be a command injection vulnerability. And in order to do this, you need to look at the application and focus on functionality that probably calls underlying system functionality. And some examples that I had here are ping and trace route. A lot of times, the ping and trace route commands that these devices have will take the input from the user and pass it to system with ping. So you would then have the ability to chain commands and not only execute ping, but execute, I don't know, RM-RF. All right, so some test examples that I have here. I have some examples for both Linux and Windows. I think you guys should be able to read these. But really, okay, assuming that the command was just config, we can put a semicolon and then put an additional command, and it's going to be executed. For Windows and Linux, we kind of do the same thing, but we can do it with pipe now instead of a semicolon. One of the more common command injection vulnerabilities that you'll find is going to be command substitution. And you have the ability to do this by putting a command in between backticks or in a $parentheses variable. And what that's going to do is first execute the command that you have in the backticks, and then it's going to take the result of that and then execute it with the original command. All right, so here's a very simple PHP script, like 2 lines, that's vulnerable to command injection, just to kind of give you guys an idea of what you could look for in web applications. This code is taking a get parameter domain, and it's passing it to Shellcode, which is the system function in PHP, and what it's going to do is execute dig, whatever command you give. And what you can see here is I passed a domain, infosec42.blogspot.com, and then I chain out a command. So the command that I chained was cat as password. The password file was returned by the web server. All right, so command injection countermeasures. Users, there's really nothing you can do. I mean, this is strictly a developer problem. So they kind of just need to take it in the butt, then you'll be all right. Avoid calling shell commands when possible. In most cases, in most cases, there's going to be an API that already exists or functionality that you want to implement. And I provide a simple example of that here. Using the Python system function in the OS module, you have the ability to execute system commands. And assuming that the dir is a variable controlled by the user, this is going to return the output of the decline into the directory dir. It's taking an input and then chaining with ls. Well, that's vulnerable to command injection. A safe alternative would be to use the lister function that the same module provides. And all that's going to do is take a directory and return the contents of the directory. If it's not a directory, okay, it's just going to complain. It's a directory. So it's not going to be vulnerable to command injection. All right, so here's the first demo. We're basically going to tie 2 vulnerabilities together here in the TriNet router. We're going to be attacking this router from a remote perspective. So this demo is going to use 2 internal IP address ranges, but they're separate subnets. They're different classical networks. So it's showing how one is segmented from the other. And what we're going to do is leverage cross-site request forgery to forge application requests. And one of the requests that we're going to forge is vulnerable to command injection. So we're going to send that request several times to execute a series of commands. And this one's a video, so I'm not doing it live.
So the one that was yes,
Kind of. I just set up 2 separate network segments. So like the WAN side of one of the routers was just a internal network. Okay. Wow, yeah, you guys can't see that at all.
That's just a way to dim the lights up.
Yeah, maybe this weekend the lights. Oh, it's kind of being great.
Very switch.
This one?
Yeah.
Go ahead.
Yeah.
Was
Looks like it went down a little bit.
Can you guys see it?
No.
Alright, forget it. We'll just talk about it. So all I'm showing you is the source code for this vulnerability. It's on the IC website, so if you're curious, you can go to the website, check out the source code. SecurityEvaluators.com, go to case studies, and you'll find both of the papers that I mentioned. My slides are also there. Alright, so basically what we're doing in this code is we're making several requests, like I said, and the first request that we're making is enabling a port forward for port 23 to the router itself. So a remote attacker, in this case, connected to port 23 from the WAN side of the router is then going to forward it to its internal port 23. So that's the first request that we set up. This exploit doesn't require that request to be there, but for my testing, it made it more stable and more reliable. So I put it there for stability purposes. The second request that we're going to make starts the telnet server. And the telnet server is going to be started. It's going to be running on port 24, if I recall, and not require any authentication and drop you right into a shell. All right. Well, the third request, we had to set up IP tables, and you would think that it'd be as simple as, or it would be as simple as, all right, I'm going to create the IP tables rule, and then I'll have access to telnet. Well, no. I found there was a race condition in this device, and as soon as you added a firewall entry, within a few seconds, that device was going to just kind of revert its firewall. So you had a very, very, very small window and a small chance to gain access to this telnet service. So what we had to do was write a small shell script that we used for command injection. That basically was a while loop that would add this rule 25 times, and then you would get in. After it ran 25 times, it would flush it, and it would run again 25 times, flush it, run again, and it rinses and repeats. Alright, so I'm going to try and fast forward this. Alright. Okay, so you guys can see that, right? Alright, so you see the source code. Actually, I apologize. 1 second. You should be able to see this part then too. Great. Alright, so that was the attachment machine. I just showed you that IP address. It was quick. Right now I'm trying to tell that to the router. Just to show you that we can't currently access the router. Port 23. Confirming that the web server started, so we can use the web server to launch the cross-site request forgery exploit. Alright, so now we're on the Windows XP machine. The operating system doesn't matter for CSRF attacks, showing you that the internal network was a Class A network of 10. We're going to log into the router. WAN IP address. 192.168.111, we try to tell that to. Alright, so here we're going to launch the cross-site request forgery attack. Obviously, the victim is then going to type this in. We were doing it in real life. But as you can see, several windows were open. It's submitting several requests to the router, and the requests were what I stated. We're enabling the telnet server, we're doing the port forwarding, we're adding the IP table rules. So now, we're going to try and get it to telnet, and it takes a few minutes because of that race condition I told you. But once we finally hit the race condition and those rules were added and we get access, the script continues to loop and we'll have access for as long as we want. So we got a root shell. Directory traversal. Alright, so this is the next form of attack that I'm going to be talking about. Who's familiar with directory traversal? Alright, morning, it's great. I like this. Alright, so what this attack allows us to do is kind of traverse from a point that we're given access to another point in the file system, I'll say, and gain access to additional content. So let's say this web application gave us access to the var www directory, and that's where like the index.html and all the application is hosted. We wouldn't have the ability to access content outside of that directory if a directory traversal vulnerability existed. And here's a small example where we're requesting the password file, and it was returned. Okay, so testing for directory traversal. Again, to really test for any vulnerability, you need to enumerate the application. And some great things to look for would be kind of like file-based functionality. So if you have an application that supports uploading files, changing files, creating files, you should definitely look there. A lot of times you'll find parameters like file name or like file destination or directory. Those are great places to look for traversal vulnerabilities in a web application. Sometimes you can't get away with simple .. You can take a step further and use simple URL encoding. This kind of allows you to bypass very terrible filters that developers implement to try and prevent directory traversal attacks. One thing that should be known is these types of vulnerabilities don't just exist in web applications. Like C programs can be vulnerable to these attacks as well. You may know them as .NET/attacks. And additionally, SMB servers are also vulnerable to directory traversal attacks. And here's an example of that. We were using Symlink, and we were, in the case of the routers, we were basically given access to like a temporary directory through one of the NAS services, SMB in this case, and we were able to create a symlink that traversed out of that restricted directory, or out of that directory that gave us access to the root file system, or anywhere else in the file system that we wanted. All right, so some, again, very simple PHP code that's vulnerable to directory traversal. This code is a get parameter file, and it's including it with var www, and I'm going to show you the contents before execution. All right, so we talked about what directory traversal is. And PHP include is kind of a step further because the code will also get executed, so you can kind of get code execution. But we're not going to talk about that specifically. What you see here is the file parameters being passed in .. to traverse out of the var www, and we go to the etc directory and we request the result.conf file, and that shows us our computer's DNS settings. All right, so directory traversal countermeasures. Developers should try not to use input in file system calls. It can be avoided. The players really don't need to do it. Perform path canonicalization, so all like symlinks and .. are resolved, and properly configure your services. And specifically, I have that whole item there for Samba. Symlinks can be disabled. If you don't want symlinks to traverse to the file system, but you still want symlinks, it can be disabled. All right, so here's an example of a directory traversal vulnerability. This one is another video, and the target this time is the D-Link DIR 865L router, and we're actually going to use two traversals here. One is going to be an SMB symlink traversal, and the other is going to be a PHP file inclusion. It should be known that these embedded devices are very small, and a lot of times the implementations of software varies or isn't standard. What I mean by that is this D-Link had a custom version of PHP that didn't have the standard include function, but it had an identical function that performed the same functionality. So what we're going to do here in this vulnerability is connect to the server, connect to the router via SMB. We're then going to create a symlink and traverse into the file system. From that point, we were then able to grab the credentials from the router, in clear text, by the way, log into the router, then abuse the file inclusion vulnerability to get remote code execution. Let's skip over the source code. Again, this code is on the IC website if you're interested. Alright, so we're going to run the script right now. And we created the sibling. We put a XML file which we can use in the file inclusion, and we're then given our root shell. So this would have been a little more clear in source code. Unfortunately, couldn't. I apologize. Check it out on the website. And I'm just showing that it was consistent access by connecting again. Alright, so now I guess we'll attempt to do a live demo. Actually, I just added this one yesterday, and I forgot to put it here, so I'm going to put this router. What this is going to do is, this is again going to abuse a symlink directory traversal vulnerability, and we have the ability to really write anywhere we wanted in the file system. So we create a symlink traversal vulnerability. Once we had access to the root file system, we were able to change the cron directory and tell the router to execute a file or command of our choice. Once that happened, all right, we're running out of time, so we might skip this vulnerability. So I want to get to the beginning one. Actually, no, I'll show you really quick. Let's do it quick. I just want to talk about it. I gotta figure out what my backtrack machine is. All this experience and whatnot. So once we get access to the router, we change the cron directory and we uploaded the telnet D binary, and we're just going to start the telnet binary. So let me see my IP address. Okay, great, you guys can see that. What's the thing now? I'm waiting for an IP, so while that boots, I will continue the presentation. So we don't have time. Alright, so the last vulnerability we're going to go over is buffer overflow. Buffer overflows are a vulnerability that exists because too much input is copied to a fixed length buffer, and what that's going to do is overflow the buffer that resides in memory and overwrite the adjacent memory. And here's a picture of buffer overflow in an x86 system. Again, these devices were MIPS, and the MIPS architecture doesn't work the same way that x86 does, but it's the same principle. Alright, so testing for buffer overflows, the way you're going to go and do it is dynamic analysis and static analysis. If you have source code, via source code, you'll probably find the overflow. If you don't have source code, fuzzing. And we talked about fuzzing and how to develop a smart template to fuzz properly. Here's a quick example of vulnerable code that will allow you to execute arbitrary code. It's a very, very, very simple C program that's just taking an argument from a user and then copying the argument into a fixed length buffer argument, like consists of 42 bytes, or it's 42 bytes in size. If you supply an argument that exceeds that length, you're going to overwrite against the memory, and that's what this picture demonstrates. It shows us running the program successfully, and it shows us running the program too much input, which base EIP contains 42, 42, 42, 42. So you guys are familiar with how buffer overflows work and how the call stack works in the program. The return address is on the stack, the return address is overwritten, and then when the function returns, that overwritten value is put in the EIP, which means we gain control of the execution flow. Okay, so buffer overflow countermeasures. Don't use unsafe functions. Compile with buffer overflow prevention techniques. So piling and making is very important. And then perform bounce checking. Just don't use unsafe functions. And for whatever reason you're going to, check the length of the input before copying to the buffer. Okay, so the MIPS architecture. Here's a quick note on the MIPS architecture. I'm not going to review because I want to show you this vulnerability. Specifically, here's the route chain that we use. that we use in this exploit against the ASUS routers. Basically, a rock chain is allowing us to take existing components of a program's source code and chain them together. So we're going to take some of the code while the application's running and get it to achieve a result that we desire, such as setting up registers containing arguments to functions that we want to call. And then we're going to, once that piece of code executes, we're going to return to the next rock gadget. And what rock gadget 1 would do would put rock gadget 2 in T9. So when we did the jump here of the Jailer, we would then jump to rock gadget 2. And we could continue to do this until all the registers are set up, our shellcode is in place, we jump to the shellcode, execute it, and get the show. Alright, I was going to go over the shellcode that I wrote specifically for this exploit, but I don't have time. This is online, so if you're interested in the shellcode, check it out. MIPS is different than x86. It's easier to read, but there are more difficulties that you have to deal with. Alright, so we're at the live demo of the buffer overflow. I guess real quick, we'll try see if we have an IP address on this link list. We'll try it. Alright, great. So the links to this. As you can see, connection reviews for telnet down here cannot get on port 23. So now we're going to run the exploit that consisted of the shellcode that I briefly showed you. Sorry I couldn't cover it, and then the rock chain. Exploit executed. Really quick, the service that we exploited was ACXD. It was coded by Broadcom. It exists in several different routers by different manufacturers. This service allows the router to scan wireless channels and choose the least congested channel. It listed on the network. I have no idea why. There's no documentation about it, so there's very little that we as attackers know about it. All right, so we ran the exploit, and as you can see, we have a show. So we're root. Questions before we run out of time?
How did the Architect router do?
How the Architect router do? The Verizon one specifically? That one wasn't too bad.
Way harder than made it.
I can honestly say that we didn't look at all the services on the device, but from a web perspective, it is as vulnerable as any other routers. So you're definitely
Track 5 clear now.